Today we're going to talk about section 8.6, geometric sequences. Just in review, a couple chapters ago we talked about arithmetic sequences where we add a number to the next number to get the next number and so on and so forth. For example, this very small arithmetic sequence here, 1, 5, 9, 13, you see each term increases by 4. So we called that number, we called that the common difference, if you remember that from a couple chapters ago. And sometimes the common difference went up, sometimes the common difference went down. Well, sometimes you have a common multiplier, a common ratio is another word for that, and that ratio can change a problem and make it extremely large or extremely small very quickly. Here our common ratio from 1, 3, 9, 27, and 81 you see is multiplying each one times 3. Now to find that common ratio, sometimes what we can do is we can divide the second term by the first term. For example, 3 divided by 1 is 3. Or 9 divided by 3 is 3. Or 27 divided by 9 is 3. Or even 81 divided by 27 is 3 on a calculator. So if all of those numbers, when you divide the number by its previous number, is the same similar number, that's called a common ratio or multiplier, and you have a geometric sequence. So let's look at example 1. In example 1 we're asked just to find that common ratio. Now we're basically told that it is a geometric sequence. So what we're going to do is we're going to say what's negative 12 divided by negative 3? Well, that's 4. Let's check it. Negative 48 divided by negative 12. Once again, 4. Negative 192 divided by negative 48. Now we need to check all three, so here you may need to use a calculator and check this out. So put in negative 192 and divide it by negative 48. And once again, the answer is 4. So in all three of these cases, a geometric sequence is true, and the common ratio, or R, equals 4. Our next problem, we have numbers alternating with positives and negatives. But we're still going to take the same pattern. We're going to say, what is 20 divided by negative 80? Well, we reduce that. That's negative 1/4. Now we look at the next one. Negative 5 over 20. Reduce that. Once again, negative 1/4. Now even if these first two work, and the third one does not work, it's not a common ratio. So now I'm going to have to take my calculator, 1.25, and divide that by negative 5. And I get negative 0.25. Well, negative 0.25 is the same as negative 1/4. So in all three cases, we have the same common ratio, and so R equals negative 1/4. Now we look at example 2, determining what the next three sequences, or the next three terms of each sequence are. To do that, we have to take a look and say, is this a geometric sequence? Well, let's take a look. What's 4 divided by negative 8? That's negative 1/2, so it looks like our multiplier is negative 1/2. Is that the case? Does it continue? Sure enough, negative 1/2 again, and 1 over negative 2, negative 1/2. So we have a geometric sequence here. So our multiplier, our ratio, is negative 1/2. So our next two terms, or next three terms in this case, would be negative 1/2 when we multiply. Let's multiply again, positive 1/4, and multiply one more time, negative 1/8. So each time when we multiply by negative 1/2, we get those three numbers. Let's look at our next sequence. 6 divided by negative 3 is negative 2. Negative 12 divided by 6 is negative 2. 24 divided by negative 12, once again negative 2. So here we do have a common ratio of negative 2. So our next three positions, all we're going to do is we're going to multiply by the common ratio, the common multiplier. So negative 48, positive 96, and negative 192. Now if you need to use a calculator for those, that's okay. It's not a problem at all. Calculators will be allowed on these kind of problems on the homework and on the quiz. Let's look at our bottom two examples. Here we're going to try to determine whether it's arithmetic or geometric. To do this, we say, well, Are we adding or subtracting something consistently, or are we multiplying by something consistently? Let's look at this first one. 12 to 8, that's a difference of 4. 8 to 4, a difference of 4. And so it looks like each of these cases, it's going down by 4. So the common difference is a -4. Therefore, this is an arithmetic sequence. Let's look at our next one. 9 to 12, that's 3. 12 to 16, that's 4. 16 to 21 and a third, that's 5 1/3. So it's not arithmetic. Let's see if it's geometric. 12 divided by 9. Well, 12 divided by 9 reduces to 4/3. There's our first one. Our second, 16 divided by 12. We divide both by 4. That reduces to 4/3 as well. It looks like we have a geometric sequence. Let's take our third. 21 and 1/3. Well, to do that, we have to say, let's go around the clock here. 63 plus 1 is 64/3 divided by 16. So 64 divided by 3 divided by 16. Well, that's 1.3 repeating. And 1.3 repeating is once again 4/3. So this is a geometric sequence, and the common ratio is 4/3. So there we have our first part of our section as we talk about this.